Assalamualaikum and hi everyone. We're from Group 1. We want to present about introduction of communication. Let's explore how communication system work in our daily life. We use communication every day when we chat and our phone, send a message or watch video online. But have you ever wondered how all the information travel from one place to others? That's where communication system come in. They make sure information move from source to a destination clearly and effectively. So let's start look at the first point, the definition of a communication system. But before that, we want to introduce my members. Okay, my name is Nur Izzatul Najab Ismail. My MNC number DN240058.
Okay, hi, my name is Daniel. In this part of the project, I will be presenting the diagram and illustration for chapter 1. I will explain the communication system using block diagram, signal representation and transmission media illustration to help you understand how information is transmitted from the source to the destination.
Hi, my name is Herlin and I will be the presenter for the important equation section for this project. In this part, I will explain several key formulas used in communication systems such as signal frequency, bandwidth, signal power, signal to noise ratio, decibel gain, and amplitude modulation. These equations are very important because they help us understand how signals are transmitted and how communication quality is analyzed in real system. I hope this explanation will help you better understand the basic concept behind communication systems.
Assalamualaikum and hi everyone. My name is Nabiha and I'm responsible for explaining the practical example and application of communication system in this project. In my section, I will show how communication system work in real life situations such as mobile phone calls, Wi-Fi internet use and radio broadcasting based on the basic components of a communication system. Thank you.
First definition of communication system. A communication system is used to send information from one point to another. This could be voice, data, image or video. Understanding this is the first step before we look at what makes up a communication system. Second, basic element of communication system. The system has 5 main elements: source, transmitter, channel, receiver and destination. Each part has its own role to make sure the information reaches the other side correctly. Next, we will start with the first element, the source of information. Source of the information. The source is where the information originates. For example, when someone speaks, their voice becomes the source. After the message is generated, it needs a path to travel which brings us to the transmission channel. Number 4, transmission channel. The channel is the medium that carries the signal from the transmitter to the receiver. It could be air, cable or fiber optic depending on the system. When the signal reaches the receiver, it can be converted back to something unstable. Number 5, receiver and destination. The receiver captures the signal of convert back into usable information. The destination is the final point where the information is delivered, like a person or a device. But during this journey, sometimes unwanted disturbance can occur. This is called noise. Lastly, noise is its effect in communication. Noise is any interface that affects the signal while it's being transmitted. It can cause distortion, delay or even loss of information. Understanding noise helps us improve communication quality, and this links nicely to our next topic on signal type and transmission method.
Today, I will explain some important formulas that are commonly used in communication systems. These formulas help us understand how signals behave, how power is measured, and how signal quality is evaluated. First is signal frequency. Frequency shows how fast a signal repeats in 1 second. It is calculated using F equals 1 over T, where T is the time period. Next is angular frequency. Angular frequency is equal to 2 pi times frequency. It is mainly used for sinusoidal signals in calculations. The third formula is bandwidth. Bandwidth is the difference between the highest and lowest frequency of a signal. It shows how much frequency range a signal uses. Next is signal power. Signal power is calculated using RMS voltage divided by resistance. It shows how much power is delivered to the circuit. Next is signal to noise ratio, or SNR. SNR compares the signal power with noise power. A higher SNR means better signal quality. Next is decibel gain. Gain in decibels shows how much a signal is amplified. It is calculated using output power over input power. Lastly is amplitude modulation, or AM. In AM, the amplitude of the carrier changes with the message signal. It is one of the basic modulation techniques in communication systems. That's all from me. We move to the next presenter.
Today, I will explain 3 practical examples and application of communication system. The first example is mobile phone call. When we speak during a phone call, our voice becomes the information source. The microphone in our phone acts as a transmitter, converting our voice into an electrical signal and modulating it. This signal is sent through the communication channel, which is the mobile phone network using radio wave. At the other end, the receiver is our friend's phone, processes and demodulated the signals. Finally, the destination is our friend's ear, where this original voice is heard clearly. This shows how communication systems allow people to talk even when they are far apart. The third example is radio broadcasting. In a radio station, the announcer voice or music is the information source. The station equipment acts as a transmitter, modulating the audio into a high-frequency carrier. The channel is free space where radio waves travel over long distance. Our car radio or home radio is the receiver and the destination is the listener ear. The system enables news and music to reach many people at the same time. These 3 examples clearly show how the basic communication system source, transmitter, channel, receiver and destination works in real life and support our daily activity. That's all for me. Thank you. The second example is Wi-Fi internet at home. When we browse the internet or watch video, our laptop or smartphone become the information source. The Wi-Fi router works as a transmitter, encoding and modulating the data. The channel is in the air where the data travels use wireless signal. Our device acts as a receiver, decoding the signal. The destination is the screen or speaker where we see image or hear sound. This system allows us to access online learning, social media and entertainment.
Okay, for this part, general communication system describe how information is transferred from a sender to a receiver. The process began at the source where information such as voice, data or video is generated. This information is then processed by the transmitter, which converts the message into a suitable signal for transmission. The signal travels through the channel, which can be a physical medium such as cable or maybe wireless medium like free space. During transmission, the signal may be affected by noise or interference. At the receiving end, the receiver extracts and reconstructs the original information from the received signal. Finally, the recovered information is delivered to the destination where it can be understood or used. Okay, next for transmitter and receiver. They work together to ensure reliable information transfer. On the transmitter side, the original message exists as a baseband signal which contains the raw information such as voice or data. The signal is then modulated into a higher frequency carrier to make it suitable for transmission over long distance. After modulation, the signal is amplified to increase its power so that it can propagate through the channel effectively. On the receiver side, the received signal is usually weak and affected by noise. Therefore, it is first amplified to improve its strength. The signal is then demodulated to extract the original baseband information from the carrier. Finally, baseband processing is performed to recover and refine the original message before it is delivered to the user. Okay, next, this diagram compare analog signal and digital signal based on their waveform characteristic. An analog signal varies continuously with time and can take any value within a given range. This type of signal is commonly used to represent natural phenomena such as human voice, temperature, and light intensity. In contrast, a digital signal consists of discrete amplitude level, typically represented by binary values such as 0 and 1. Digital signals are more robust against noise and are widely used in modern communication systems, including computer, mobile network, and maybe digital data transmission. Okay, for this diagram, illustrate free space wireless communication, where signal are transferred through the air as electromagnetic wave. The transmitter convert electrical signal into electromagnetic wave, which propagate through free space and are received by the receiver antenna. Free space communication does not require physical cable, making it suitable for applications such as mobile communication, satellite link, and Wi-Fi system. However, during propagation, the signal may experience attenuation, noise, and interference, which can reduce signal strength and affect communication quality at the receiver. Okay, for the last of my part, this diagram highlight the electromagnetic spectrum, which represent the full range of electromagnetic wave arranged according to frequency and wavelength. In communication system, different frequency band are used depending on the application. Radio wave and microwave are the most commonly used in communication system because they can propagate over long distance and penetrate obstacles. As frequency increase, the wavelength becomes shorter, enabling higher data rate, but the transmission range usually becomes shorter and more susceptible to attenuation and interference.
That's all from Group 1. Thank you for listening.